Okay, let's talk about another version of angles. This is a new one. This is a new situation. Okay, these are angles that happen to be inside the circle, right? Which means when we say they are inside, we've tried to emphasize this along the way. That means they are not a central angle, because there's the center of the circle, and this vertex is here, and they are not inscribed. All right, they are some other location. And so obviously, when we look at this, we're trying to figure out the angle right here and right here. All right, and they should be the same as each other because we have our vertical angle rule. So I can look at this, and if you start to look at this angle opens up to this arc, and this arc right here is 10, 20, 30. That arc right there is 30, but that angle's not 30 because this one down here is 1, 2, 11, so that's 110. So there's no way that we could say that that one's 110 and that one's 30. That would not make sense because these are supposed to be the same as each other. All right. So how is this different? Oh, I think we probably answered that. We should put this right here. Okay. This is how this one is different. It's not central. It's not inscribed. It's inside. And if I measure angle X right here, we should figure out using a protractor that this thing right here is 70 degrees. All right, so how can we figure out what's the correlation between numbers right here to get me 70 degrees? Angle X equals 70. Well, if you really look at it and you do enough of these, you'll start to see a pattern here, and you're going to figure out that it's the average. It's the average of those two angles. So in other words, it equals 30 plus 110 divided by 2. That is the relationship. And so we say, the rule is to find an inside angle. It equals arc 1 plus arc 2 divided by 2. It's the average. So that's the rule. That's what we're discovering here. Okay, so it's not really a hard concept. It's just going to look a little different to you than the inscribed and the central ones. Now, I do want to prove this to you in a mathematical way, like doing our proofs. And I'm going to show you this. I've already got it written down. I hope you're listening. But it says, consider this angle right here. And we do know that this angle, here's my two chords that cross, which is the same situation here. You have two chords that cross. And all we did was connect one of these to make a triangle because we're really good at triangles. So if you connect one to make a triangle and you still look at this angle right here, well, this angle is equal to those two added together. And that is a rule called the triangle exterior angle theorem. We used it on a proof just a few pages back. So this exterior angle of a triangle is equal to the sum of the remote interior. We've been learning that for a while. Then we go ahead and point out, well, this one actually is half of arc EG, all right, and it says it right here. And this one opens up to HK, so it's half of arc HK. That's the inscribed angle theorem. So that's those two statements. And then what we do is we take statement 3, and we plug in for angle E. For angle E, we put this expression in there. And for angle H, I put this arc in there. But it's half of those. So this is substitution. All I'm doing is substitution property. And then I factor out the 1/2. So really, when you look at this final answer right here, angle KFH, where I have the arc, is equal to HK plus EG added together and divided by 2. That's the same rule and the same proof that we said right here. It's the 110 and the 30 added together, and then you divide by 2. So this is the formal proof of it. All right. Again, we call it the interior angles of a circle theorem, or we'll say interior angle theorem, but it only works. This is for circles. Okay. And so what follows, of course, as you can guess, is a few problems. There are 6 problems right here that deal with this same concept. It's very straightforward to use. For example, I know that this angle right here is the average of those two. So I would say 60 plus 70 divided by 2, and I would get that angle X here is 65 degrees. We could go ahead and make the argument for the other two angles because these two are linear pairs with 65. Like you can find that one in order to help you find these. That means these would be 115. So we're back to doing, I mean, if it came down to that, or if you were having to use this somewhere else on something, all right? Them two are 115, those two are 65. You can use this idea to solve multiple problems, multiple situations. You should be able to apply that. And then what follows here in this packet, this is where this gets fun. I know your idea of fun, my idea of fun might be a little different, but more challenging, I should say, like a puzzle, all right, is to use some of these ideas to solve problems. It says mixed practice. There's all these situations. Oh, hey, look, we're back to a quadrilateral. Maybe you got to use your quadrilateral rule, all right? This one has some central angles, but it also has some angles in here, like these two that are on the inside. You might could use some of those inside angle rules, but be careful. These are central angle rules. All right. Some of these right here could be inscribed angle rules. That could have all three of our types of angles in there, which would be really good for us. Just read and label, and then you would erase that and kind of start the new problem over when you're doing each of these are separate problems. Okay. And you're just into doing that. All right. Notice this one. That's not the center of the circle. So don't use our center of a circle rule. That is, and that means that's a diameter. So now we're back to thinking 180 and 180. So that might lead us to some stuff. This is all review. All right. This one has a diameter, but it also has a quadrilateral. So it just looks complicated, but you could go back and use our quadrilateral rules on that. This one has quite a few things, a diameter. It's got some angles inside this circle right here, but it also has some inscribed angles that open up, like that angle right there opens up to the 86. That could get you started there. You might not forget, too, that triangle sum to 180. I could use that rule inside here. That's where I was saying it becomes more like a puzzle problem, and you're using the rules and the relationships that we learned, and you're solving problems. Okay? And you could stop right here on the bottom of page 14.